Hello and welcome to this video. Today I will be trying to explain to you something new about electrical engineering. I will tell you what electrical engineering people do, what can you learn if you decide this to be your major, which skills and knowledge are the most necessary for major in electrical engineering, and how can we apply the fundamentals of electrical engineering in the real world. Electricity serves a vital function in our modern world. As electrical engineers work with electricity every day, designing new systems and making repairs to other applications in order to keep our world electrified. As an electrical engineering major, you will study how electricity works, how it is generated, and how it is used. You will work on developing and designing all types of electronic equipment, which includes broadcast and communication systems, MP3 players, GPS systems, and the electrical systems of automobiles and aircrafts. Computer hardware is also part of this field. So, is the electrical engineering the right major for you? Here are some skills that you need to bring with yourself if you decide to study this field. You will learn about application of math formulas and physics laws here. Courses you will come across in this major can include statistics, calculus, circuit analysis and design, physics, digital systems, electrodynamics, technical and writing field engineering, semiconductor technology, and electric components. How can you decide is the electrical engineering the right major for you? If you like math and physics, you are curious to find out how electricity works, you enjoy taking things apart and putting them back together, you want to learn how computers, wireless stations, power plants work, or any device that runs on electricity. Or maybe you like new technology from this field. Here are some examples of what you can learn in electrical engineering. Electricity is delivered to our homes via power lines, and it is produced in power plants. From hydroelectric to wind, biomass, solar, waves, nuclear, geothermal power plants. We have a variety of ways how can we produce electrical energy. Machines that produce electricity are called generators. And in essence, they use Faraday's law of induction as a principle to generate electricity, which states that any change in the magnetic environment of a coil of a wire will cause a voltage or electromotive force to be induced in the coil. No matter how the change is produced, the voltage will be generated. The change could be produced by changing the magnetic field strength, moving a magnet toward or away from the coil, moving the coil into or out of the magnetic field, rotating the coil relative to the magnet, etc. Faraday's law of electromagnetic induction is also used at the hydropower plants. It is used when water moves the turbine, and due to this mechanical movement, the turbine will make the magnetic field inside of the generators, and the coils will generate the electric field. In real life, you can use Faraday's law to generate electricity, and you can use it to calculate or to create voltage. This is one example of application of Faraday's law. If we use an iron core and we apply 120 volts at 60 Hz to the coil, a large alternating magnetic field will be produced. The magnetic field alternates 60 times per second, being produced by an AC, or alternating current, from an iron core coil. The changing magnetic field induces a voltage in the coil, which is sufficient to light the bulb if it is close enough. When you bring the bulb close enough for it to produce light, you are demonstrating the action of a transformer, which uses the changing magnetic field produced by the current in one coil to induce a voltage into a second coil. This is an example of a Faraday's law. And here we can see the live demonstration of Faraday's law. If we move the coil close enough to the core, the change in the magnetic field will induce in the coil electromotive force, and the light bulb, which is connected to the coil, will gonna shine. The faster the change in the magnetic field, the faster we move toward or out of the core, in the coil will gonna be generated more electromotive force and the light bulb will shine brighter. Some real-life application of Faraday's laws can be seen in the production of electrical generators, in the current lamps, in the magnetic flow meters, in motors, induction motors, in the inductors, in transformers, wireless energy transfer, pickups. In this example, we can see the hydropower plant, and if the water comes from the reservoir and goes around the turbine, which is connected to a generator, when water moves the turbine, which is connected to a generator, due to this, the turbine will make the magnetic field inside of the generator, and the coils of the generator will generate electric fields. In this station, we can see the use of Faraday's law, because the law states that an electric field occurs when a magnetic field in that area changes by time. And here we can see on these pictures few electrical generators inside of the hydropower plant. Electrical generator uses mechanical energy to generate electricity. Inside the generator is a wire coil in a magnetic field. When the device is used, current is passed through the coil, and the interaction of the magnetic field with the current causes the coil to spin, making electricity. Another example is at the AC generators. They utilize Faraday's law of induction by spinning a coil at a constant rate in a magnetic field to induce an electromotive force, or short EMF. The coil area and the magnetic field are kept constant, and as a result, it will produce AC electricity. This was a short introduction video about electrical engineering. There is a lot more to discover. If you find this video interesting, then come and explore. Who knows? Maybe you can be the next Tesla.